Hello good day viewers. In this tutorial we are going to find a solution to this interesting complex equation. We want to find that complex number z such that iz to the third power minus z plus z squared plus I equal to 0. Alright, let's get started. I would like to remind you something very important. The square root of negative 1 is equal to I, right? Therefore, if you square both sides, you have negative 1 to be equal to I squared. So you can see we have a coefficient of z here to be negative 1, and hence we can replace it with I squared. So let's do that. Therefore, our equation becomes I z to the third power. Then instead of minus 1, we have I squared. Then z, we have plus z squared plus I, the whole of this equal to 0. Now we can factorize in batches. We're going to factorize the first two. What do we have here in common? We have iz in common. So I can bring iz here. Inside, I is already out. 1z is out, so we have z squared plus z is already out, and one of the i's is out. We have I here. Then from the second term, we have only 1 in common. So plus 1 multiplied by z squared plus I. The whole of this equal to 0. Now you can see that z squared plus I is what we have in common. So we can further factorize it. So this becomes z squared plus I multiplied by, we have iz here, iz, then plus 1. The whole of this equal to 0. Now we have two factors. Either z squared plus I equal to 0 or iz plus 1 equal to 0. This sounds very simple, so let us solve it first. Iz equals negative 1. But what can you remember about negative 1? Negative 1 is nothing but I squared. So we can replace it with I squared. So we have I times z to be equal to I squared. So if I multiplied by z is I squared, it implies that z must be I, because I times I will give us I squared. And you can simply divide both sides by I. Hence z equal to I. This is one of the solutions. Then we come back here. From here we can take I to the other side. So this is equal to negative I, which we can write as z squared to be equal to 0 minus I, because this is a complex number where the real part is 0. So what do we do next? We take the square root of both sides. We have z to be equal to plus or minus the square root of 0 minus I. And square root can be written as what? An exponent of 1 over 2. This is equal to plus or minus 0 minus I raised to the power of 1 over 2. Now let us write this one in polar form. We know that cosine of pi over 2 is the same thing as 0. So this is equal to plus or minus cosine of pi divided by 2. We know that the coefficient of I here is negative 1, and the sine of negative pi over 2 is negative 1. So we write plus sine, or we can attach I before the sine, I sine of negative pi divided by 2, right? Remember, raised to the power of 1 over 2. If you like, you can bring it back. Cosine of pi divided by 2 is 0. Sine of negative pi divided by 2 is negative 1 times I is negative I, right? So we have not done anything, just a conversion. And how can we expand this? According to De Moivre's theorem, we can multiply the argument by the exponent. So let's do that. So this is equal to plus or minus cosine of what? Pi divided by 4. Once you multiply this by this, you're going to obtain pi divided by 4. Then plus I sine of negative pi divided by 4. And let's simplify. This is equal to plus or minus cosine of pi divided by 4 is nothing but root 2 divided by 2, then plus I. Sine of negative pi divided by 4 is what? Negative root 2 divided by 2. And I can simplify it because we have negative positive, it will become negative. So this is equal to plus or minus square root of 2 divided by 2 minus root 2 divided by 2i. This is the second solution, but if you like, you can break it apart because we have plus or minus. So we can say that z is either equal to root 2 divided by 2 minus root 2 divided by 2i, or z equal to, if I use minus, I have a minus root 2 divided by 2. The minus will affect this one, it becomes positive root 2 divided by 2i. These are two solutions, but remember we have another one here, which is z equal to I. So the last solution here is z equal to I, which we can write as 0 plus I. That is real and imaginary parts. All of these contain real and imaginary parts. So these are the solutions to this problem. Remember, it is cubic, so we expect 3 solutions. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.